In this video, we'll be trying to solve another question on work, energy, and power. Okay, we're looking at another question on work done on an inclined plane. The question here says a film star in a car together 720 kilogram drives 4.8 meters down an inclined plane as indicated in the picture. That's this image here. Okay, she starts from rest. The car experiences a frictional force of 23 Newton and the engine exerts a force of 200 Newton. The A part says calculate the work done on the car by the engine. The B part says calculate the velocity of the car after moving 4.8 meters. Okay, all right, let's get this done. So solution there. Solution to this question. Solution. Now, to solve this question here, as usual, our first task will be to list out given parameters. Okay, so given, what and what are we given in this question? The first we are given there, if you look at this, it says a film star in a car together 720 kilogram. So the mass of the film star and the car combined, let's call it M, it's equal to 720 kilogram. Next up, it says drives 4.8 meters down. All right. So number 2, the distance on the inclined plane. So let's call this distance. All right. Distance on the inclined plane that is being moved is equal to 4.8 meters. So I have 4.8 meters. Okay. Next, it said down an inclined plane as indicated in the picture. So you have this one here. She starts from rest. If she starts from rest, the concept about starting from rest is that initial velocity, number 3, she starts from rest. So initial velocity u, it's equal to 0. So we know that from the idea of motion, that when a body starts from rest, its initial velocity is u. Okay, moving on, they said the car experiences a frictional force of 23 Newton. So number 4, they're given frictional force, frictional force, that's FF, it's equal to 23 Newton. Okay, what next there? Said and the engine exerts a force of 200 Newton. So we have number 5, the engine force. Okay, so engine force, that's the force exerted by the engine. Engine force, let's call this F subscript E. It said is equal to 200 Newton. You have this. So what's left here? All right, the A part is calculate the work done on the car by the engine. That's the first task. Now for this question, our first concept here would be to draw the free body diagram for this question. So how do we do that? First things first, let's draw the inclined plane. Now representing this, I'll just come down here. Let me try to draw the inclined plane. Let's say starting from here. So bring this down here. Then we'll bring this way. They'll bring this down this way. So I have this. All right. Now, if you look at the question here, observe that the angle given 42 degrees is the angle with which this inclined plane makes with the vertical line. All right, a vertical line here, and we'll just represent that one there. So bring this here as 42. So we're given here as 42 degrees. We have this. But if you observe that in our previous examples, we always take this other angle here, which is this one here. We'll call this theta. All right. So normally the angle we use is the angle between the inclined plane, this, and the horizontal line, this. All right. So take this angle here, the angle between the inclined plane and the horizontal line, not the vertical line. So we're using the concept of trigonometry now to find the value of theta. How do we get theta? We know fully well that angles, the sum of angles in a triangle is equal to 180 degrees. And of course, this is 90 degrees already. So it becomes 90 degrees plus 42 degrees plus theta is equal to 180. All right, that's the concept. So to have that 90 degrees, that's this part here, okay, plus 42 degrees plus this value here, theta, plus theta, it's equal to 180 degrees. Now, let's get a calculator and sum this. If you punch 90 degrees plus 42 degrees, you'd have 132 degrees. Okay, so I have this as 132 degrees. 132 degrees plus theta, it's equal to 180 degrees. So theta, it's equal to 180 minus 132, and that's equal to 180 minus 132, that's equal to 48 degrees. So this is what we'd use in calculating this question. Okay, so please take note, we need this value here. That's 48 degrees. That's the value. All right, so we've gotten this angle here. Next up, we'll try to represent this girl and the car here on the inclined plane. So to do that, all you have to do is put this here, and then try to draw this way. All right, so this is the girl in the car. All right, this is the girl in the car. We'll call this M. All right, let's call this M. M represents the girl in the car. Now, in this question like this, we want to draw a free body diagram. That is a diagram that indicates all the forces in this question. So for this question here, what are the forces in play? Now, first things first, observe that this girl is moving downwards this way, right? And she's driving downwards this way because the engine, all right, the engine is moving the car downwards. That means F engine is acting downwards. That's the concept, okay? Because the force of the engine is what she's driving with to move her downwards. So the first thing we have there is F engine going downwards. So from here, the first force is F engine. I would come here, bring this way, this way. Let's call this Fe. We said Fe means F engine. Okay, that's the first force there. Next up again, if you look at this, they also said the car experiences a frictional force. Now we know that frictional force acts in the opposite direction of the motion of a body. Hence, if this girl or if this film star is traveling downwards this way, you can observe that the frictional force will act in the opposite direction. So frictional force will be here. That's the concept. So frictional force is in the opposite direction. Let's add that one there. Going up here, you have frictional force. So put this way here. Let's call this FF frictional force. Okay. What else acts here? Recall that in our previous class we've said in the concept of motion on an inclined plane that the force that pulls a body down an inclined plane, this we've discussed this in our previous class, is given by mg sine of theta. All right, we said this in our previous class. Okay, so that one also comes to play. That's the final force there. Okay, we'll have mg sine theta. So coming back to this, I'll add it in this direction. All right, it pulls this downward. Excuse me, this way. All right, this way. So have this as mg sine of theta. So we have this. All right, so basically these are the three forces in play in this question. All right, so we have this. If you want to, you could bring this downward here, this and this, and say the mass m, it's equal to the value of the mass is given as 720 kilogram. 720 kilogram. We have this. Of course, the normal force will go this way here if you want to. Although we don't need it in this question, all right, but we can still add this here. Normal force N. Okay, let's put it this way, N here. All right, so basically this is a free body diagram. There's also mg this way. There's also mg cos theta, but we don't need that for now. These are the most important forces at play in this question. So having got this here, what's the A part there? The A part says calculate the work done on the engine, on the car by the engine. So A, work done on the car, work done on the car. All right, let's see this by the engine. All right, on the car by the engine. Now, how do we solve the work done on the car by the engine? How do we solve this? Now, for this, recall that work done W is equal to force times distance, right? Now, if this is true, the work done by the engine, let's call this W engine, it's equal to force by the engine, force engine times the distance traveled. That's all right? And this is equal to the force of the engine from the question here. If you look at this, engine force is 200 Newton. That becomes 200 times the distance. In this case, observe that we use distance as S. So I'll just come here, change this to S instead. It's the same thing. So this times 4.8. All right, this is the work done, W of or by the engine. All right, that's equal to, so I'll take my calculator, I'll punch 200 times 4.8, and that gives you about 960. Okay, so this is equal to 960 joules, and this is equal to 960 joules. This is the answer to this question. All right, so that's simply this. All right, so just focus on the engine force, because they said the work done by the car or on the car by the engine. So I'll just focus on just the engine, and that's it. Let's get the B part there. What's the B part? Let's see this. The B part there says calculate the velocity of the car after moving 4.8 meters. All right, B part, velocity of the car after 4.8 meters. Let's solve that question. Velocity of the car after 4.8 meters, 4.8 meters, okay, or after moving 4.8 meters, same thing. Now, how do we find the velocity of the car after moving 4.8 meters? What we use here is called the principle of the conservation of mechanical energy. All right, that's what we use here. So we said using the principle of the conservation of mechanical energy, of the conservation of mechanical energy. So mechanical energy. All right. Now, the mathematical form of this is that the net work done, let's call work net, the net work done, right, it's equal to the change in kinetic energy of a body. This is a mathematical form of representing the principle of conservation of mechanical energy. Okay, the total work done or the net work done for a system is equal to the change in the kinetic energy. Now, when we say net work done, network or work nets, let's get this work nets. Excuse me. Work nets, that's the total work. If I say work total or work net is equal to, now to get work net, it becomes the force net. All right, remember that work is equal to force times distance. It becomes force net times distance. Of course, distance covered is already given in the question. So work usually is equal to force times distance. So the force net, the work net will be equal to the net force times distance. Do we have a distance in the question? Yes, we're given 4.8. But what's the net force? That becomes the question. What is the net force? How do we get the net force? Now, in getting the net force, let's get this one first. Let's get force net or the total force or the net force. They all mean the same thing, okay? Net force is equal to get your net force, all you have to do is to consider the forces at play here. And this is why a free body diagram is very important. Consider the forces at play in this question here. Okay, what force and what force do you have here? The first force you have there is the force by the engine. So it becomes engine force. Okay, we'll take this as engine force. So FE, engine force. Again, apart from this, again, observe that the body or the girl was driving downwards. That means the direction of the motion of the girl is this way. Let's use this way here. Let's use this let's call D. Right, let's call this D. So D is simply the direction of motion of the girl. All right, observe that FE is in the same direction as the motion of the girl, so FE was positive. Again, observe that mg sine theta, this one here, is in the same direction as the motion of the girl, the same direction, so it becomes positive. So after FE, I'll write a positive, so positive mg sine of theta. Next up, my next force there would now be finally the frictional force, this one here. But observe that frictional force and the direction are opposite. The direction is pointing downwards, frictional force is pointing upwards. So since it's in the opposite direction, it becomes what there? Negative. So it becomes minus the frictional force. Minus frictional force. So I have this. So basically, this is how you get the net force, okay? Look at the direction of the motion of the body. Then, if the force is going in the same direction as the motion of the body, it becomes positive. If it is going in the opposite direction, it becomes negative. Let's impute values here. This is equal to the engine force from the question there. If you look at the engine force, they gave the value of 200 Newton. So it becomes 200 plus mg sine theta. What's the value of m? 720 times what's g? 9.8. All right. Then sine of theta, the value of theta there as we got was 48 degrees. That's this one here. All right. So this into 48 minus the frictional force. From the question there, the frictional force was given to us as 23 Newton. Okay, now let's solve this. This is equal to, this gives you equal to 200 plus, I'll get my calculator, I'll punch 720. 720 times 9.8 sine 48. That's about 52. This is 5243.63 approximately, then minus 23. That means from here, this is equal to the net force, let's call it force net, right? The net force or the total force here, force net, it's equal to, get your calculator, you punch 200 plus 5243.63 minus 23. That's about 5420.63. Of course, force is in Newton, so this becomes this in Newton. This is my net force. Now, having got my net force now, I can now multiply it with distance to get my net work. All right. From here, therefore, we can say that the total work done or the net work, net work is equal to the force net times distance s. The force net is 5420.63 times the distance. The distance in this question, it's about, let's see this again, 4.8. Okay, that's times 4.8. So this times 4.8. Let's get this value here. 5420.63 times 4.8. That would give you 26,019.02 approximately 0.02. This is work done, is in joules. This becomes the value of the net work. All right, let's call this work net. This is the net work done. All right, so we have this. All right, so we have this as a net work done. What's the next task there? Now going back, remember we have to find the velocity, all right, of the car. So how do we do that? They said the network whose value we found is equal to change in kinetic energy. So this value, network 26019.02, this value, it's equal to change in kinetic energy. That's change in kinetic energy. But recall that kinetic energy, just a bit of a recall, kinetic energy is equal to half times mass times velocity squared. Now we know that this will be equal to, if we say change in kinetic energy, it becomes half into mass does not change, but then velocity can change. So it becomes final velocity v squared minus half times mass times initial velocity. So this is how we get change in velocity, okay? If I factorize this, I have half mass, it becomes half into mass. All right, half mass, I'm left with v squared minus u squared. So basically this is the formula we use to calculate the change in kinetic energy. Okay, half mass into v squared minus u squared. So this is equal to half mass into v squared minus u squared. Now this v squared is what you ask calculate. All right, the velocity of the body after after it moves to 4.8 meters. That's what you ask to find. But what's the value of u? That becomes the question. Now going back to my question, they said the car starts from rest. We're given that. All right, so we said when it starts from rest, initial velocity u is equal to 0. So go back to this. Let's impute values here. I'll have that 26019.02 is equal to half into mass. The mass again is 720, so half times 720 into v squared. We have to find v squared minus u squared. Starts from rest, it becomes 0 squared. That's u squared. All right, with this we know that 0 squared cancels out, so it's off. We're left with v squared here. Let's impute the values. 26019.02, so I have 26019.02, it's equal to half into m, 720 into v squared. All right, minus u squared is off. 26019.02. All right, so minus u squared is off. Now let's solve this. This is 26019.02. It's equal to, so you punch half 1 over 2 times, so in bracket 1 over 2 or 0.5 times 720, that gives you 360. So 360 into v squared. To get v squared, I'll divide here and divide here by 360, divide here by 360, divide here by 360. This cancels this. So from here, what do you have next there? You have 26019.02 divided by 360. I have this as 72.28 approximately. Okay, let's take 4 decimal places. 72.2751 approximately 2751. It's equal to v squared. So to get the value of v, we'll simply take square roots. Okay, so v would now be equal to the square root of 72.2751. So v then is now equal to, we'll take the square root of 72.2751. And if I do that, my answer here is 8.5 in 1 decimal place. Of course, velocity is in meter per second. So this becomes the answer to this question. So the answer to this question here is simply 8.5 meter per second. And that is how we solve this question. Alright, guys. So that's how we solve this question. Now let me give you a task. Okay, so this is now your own task. You're having the same question here. What if the engine exerted a force of 800 Newton, so 800 here, and this moves 6.8 meters down the inclined plane, and this is, let's take this as not 23, but 45 Newton. All right, so we have this all together as 950 kilogram. All right, so you have this, okay, of course 6.8 here. All right, so you have this question here. Now here's your own task. You solve this. Leave the question. You leave your answer in the comment section. Now take this as your own task. A film star in a car, together 950 kilogram, drives 6.8 meters down an inclined plane as indicated in the picture. That's the same picture here. Okay. Perhaps I should change this from 42 to 23 or 22. Right. 22 degrees there. Okay, she starts from rest. The car experiences a frictional force of 45 Newton and the engine exerts a force of 800 Newton. A says calculate the work done on the car by the engine. B says calculate the velocity of the car after moving 6.8 meters. Okay, so this is your task. Solve this question and leave your answer in the comment section, and I will tell you if you're correct or not. All right. Alright guys, so don't forget that you can check out my available courses on my website. Simply visit www jonahemmanuel.com/courses, or you can look at the available books at www.jonahemmanuel.com/books. All right, do well to register an account to the website and then proceed to get any of the available courses or books. You can also join my channel membership to get access to exclusive classes for just channel members. All right, I'll leave a link to my website as well as to join my channel membership in the video description. Also, I'll leave a link to our WhatsApp channel. All right, so join and then you get updates on our WhatsApp channel. All right. Okay guys, so if you enjoyed this video, don't forget to hit the like button, like this video, leave a comment. In the comment, tell us if you enjoyed this video, all right? And of course, I give you a task, leave the answer to that question in the video description. Don't forget to also subscribe. If it's your first time here or you're yet to subscribe, please do what to subscribe, hit the bell icon and select all so that you get notified whenever we upload a new content. Finally, do well to share this video to your friends so that they can also learn. Thank you and see you in our next class.